and Lake the Phoenix. I too shall rise again.
Hey guys, and welcome back. So in this episode we're going to be building the new power supply for the Yamaha CX5. And this, as I stated in the last video about the Yamaha, the original power supply was a bit dodgy, and when I took it out and replaced it in the short term with a PC power supply, taking the 5, the 12 and the minus 12, I found that it ran fine. It booted up, and the HDMI unit booted up every time and fired up onto the MS DOS screen. With the original power supply in, it would sometimes boot to the display, which is the default one for the Tang, which told you that it was doing a self-test and it was running fine itself, but it was not talking to the motherboard. And I'm picking there's a fault in that power supply. As if you watched the last video and the original series when I first did this machine, you'll see that there was an issue with the power supply along the way, and we repaired it, had it working, but I'm thinking it's just age that's gotten this thing to where it is. So anyway guys, grab yourself a snack, a hot or a cold drink, depending on when it is, and a comfy chair at least. And let's have a look at building a new power supply. So guys, we're getting ready to build this power supply. So I have me plugs and sockets. I have the power supply. It's still shrink wrapped up from out of the box, and this is the T50B, which gives us the it gives us 5 amps at 5 volts. It gives us 1 amp at 12 volts plus and 1 amp at 12 volts minus. Now we don't need that much. I think the 5 volts maximum draws about 2.5 on the original, 300 on the plus 12, 300 milliamps on the plus 12, and 180 milliamps on the minus 12. Now, as I was saying in one of the last videos, these MSXs didn't come out with the optional cards already in them, or the optional hardware you can put onto them to run them, and so putting more into it draws more out of the power supply, and I'm wondering if this may be what's caused this other one to actually start to fail. So that's why I decided I'd go with something with a bit more guts in it, and if we're plugging more devices in, then it gives us a little bit more leeway to go with. I've got to sort out the wiring for the plug. Now the next thing, I did up a file for this, and this is the case. Now this is done on a 220 by 220 bed. It's pushing it to the limits, and I notice there's a slight little bit of curl on the corners, and that's because I'm right near the edge of the bed of the printer, and it gets a bit cooler there. So, but this is our case. As you can see, it's recessed Yamaha CX5. That is the on-off power switch. That is for an LED light. I'm not 100% sure, and as you can see, this is see-through like this for heat to get out, and you can see that's the back. It has a lip around it, so this piece recesses inside the case. Now I ran out of white filament when I was doing it, and because of the amount of time it was taking to print, I cut and spliced in the only other filament I had on hand at that time, which was black. So this is half white and half black. So anyway, it looks quite cool, I think. But in this end here, this is for your power in through your 3-pin power connector like your PCs have, and this is for the cable. This is for the cable coming out to go to the plug to plug into it. Alright, and in the bottom there's a recess, and that's for the power supply to sit into. And of course there's the 4 screw holes for screwing the lid down on when it sits on top. Now this, I made this a fraction bigger, the base, the gap in the base a fraction bigger. And looking back on this case, if I was to redesign it again, I would probably put another pair of mounts in the middle here, just so there's no bowing in the case at any time. But I take this, drop that down, and that sits in the recess I put in there really, really well. Now, this is not a high-end printer, guys. This is probably one of the cheapest printers you can buy on the market for the quality you get out of it. And it is along the lines of a Prusa 3, the i3, and this is a Solvo, an SOVOL 6 SV06. It's an older model now. It's probably about 3 years old now. They do a 7, they do a 6 plus, they do all sorts of models, and they do an 8, and they're getting into the XYZ rather than the bed slingers now as well, which means they come with Clipper rather than Marlin, which is what mine's running. And with Clipper software and that, they can go so much faster and print so much better and better quality. But this, I'm actually really impressed with the quality of this printer. So anyway, this just sits on here, and it'll sit on here, and it just screw the holes in. As I say, that's for an on-off switch there. And so yeah, and that's it, and it sits in here really, really nice. So that's where we're up to. So, and the other thing, I sort of thought I might put a couple of little sponge rubber feet in the corners, so that when this lid comes in and screws down, it just stops it wanting to jump up and jump out. But that's where I'm at with this, and check the voltages on here so I can wire it up with this, and I can wire up the cable to come out and that plug, and do the switches and everything else on it, and we'll be good to go. And as I say, this is not the final, this is the first print I did, and as I said from the previous video, I had to try and get this reset up because I haven't used it in so long. And this is not on its finest setting either. This is on sort of general run-of-the-mill setting, sort of standard, and you can actually hear it's a little rough on the sides, but I think it's perfectly fine for what it is. And yeah, so just going to make this cable up and put the rest of it together. So I will go through and grab all the rest of the bits I need, and we will start building this thing and putting it together. Now, a lot of your parts too, you don't need to buy brand new. Like your power connectors go in here, the 3-pin ones. You got any old PC power supplies? Have a look there. You probably have some there, you can grab them off. Power switches the same. Any electronic gear that you're going to get rid of and that, check see what the switches are. Cable, the same. Look for something, the amount of wires you need, something that'll handle that current. Grab those cables. So I mean, there's all sorts of ways you can get stuff that you need to build these. And I mean, I'm looking at a PC power supply because the older ones with the switches on them, that's mains rated, which will be more than enough than this needs to run. And I'll use that for wiring from the socket to here and up to the switch. So, you know, you don't have to go out of your way. This is what I'm trying to say. The more stuff you can go through and sort out yourself and strip down yourself, the cheaper it'll be for you to build stuff like this. But I will make these available. As I say, there's not. I was going to look at putting in a circuit board in here for the. Oh, now it fits so well I can't get the lid off. To come back into here for the switching and stuff, but I'm not going to. So the machine itself doesn't turn on until the 5-volt rail goes through it. So what I'm going to do is I'm going to take the 5-volt rail from here, and it will go into the machine, and then from the machine, I'm going to try and work that out now, I'm pretty sure, for the switch anyway. So we'd go from here into the machine, then from the other side of the switch to the machine so it runs. So that's what we're going to do with it, and that'll get that sorted. I think that's how it works. I have to double check that. But yeah, I think that should work. That should be fine. Yeah, I think so. I don't think we have an issue. I'll come to that when we get down to it. I need to look into it a little bit more for that side of the power switch. I mean, failing that, we have the main switch up here which can turn the unit on and off. So I think that would be fine there. And that we are actually regulating it here as well, which is good. So yeah, I think that would be the way to do it. Alright guys, so I will dig out the other parts for this and we'll get into building ourselves a power supply. See you shortly. Okay, so I went through trying to make these cables, and then it was like getting enough wires for a cable to make these up. I just went online and bought a 13 to 13 male, 1.5 meters long, cut it in the middle. That gives me 2 of these. That gives me 1 spare if I cock this up, or if I ever need another one, I've got a spare one. So I've just cut this and I've taken off about a centimetre, just over a centimetre of the end here, and this is just shielding off the end, which we're not really worried about because a lot of this is used for just power. There's no audio or anything like that going through it, which some of these cables are used for, these 13 pin cables. So we're just taking that, put the sheathing on there, and then these are all the extra wires. And so what I need to do is I need to grab one of those connectors that can go onto here, the females, and I'll put that on there, and then I can meter the ends of the wires to the plugs, and then I can work out which one is which, so I know what cable goes to what pin that wires up in here for the 5, 12 and minus 12 in the ground. So I will have to dig out me sockets, and I will do that and work out what the pin configuration is on this, and then I'll know by the colours what one goes where, and then we can start putting this together and put the power jack in and the switch, that type of thing. At this stage I'm going to look at making a little board up with some maybe solid state relays or a relay driven thing, so that the 5 volts can turn all the power on or turn all the power off, and that'll come from the switch on the MSX that's on the side, the on off switch. So when you switch that on, because those come back into here, because the original board had a circuit for them, so they'll come back into here, and then a 5 volt, a 12, a minus 12, and the ground can be connected all the time, but those 3 will go through an isolation relay, and that, so when you turn that switch on the PC, it will allow the power through to the machine, whereas the power switch that's going to be on the lid here, that's only to turn this on and off. So that'll go from the mains here, so that'll come in here to the switch, from the switch to here. Then the outputs are what are going to go through that relay into this cable. Alrighty, so that's my thinking on it, but for now I'm just going to wire them, and I'm going to add in that other circuit later on. It's just something I'm not 100% sure on. I have also done another case, which I will show you shortly. The other case is grey, and that was actually done in PETG, which is a bit more forgiving than this, a bit more shock resistant than PLA, and it's got the extra mounts in the middle that I was talking about putting in. So there's that as well to go for this all to go into. But I can use this as a starting point, and if I need to make things like holes bigger and stuff like that, I can do all that on this to get it all right. Alright guys, so I will find me a plug to go on the end of this 13 pin connector, and we will try and sort this out. See you shortly. Hey guys, so a little bit of a hiccup. I was recording and we had a power cut. Got some nasty weather here at the moment, up to 130 km/h winds, but we battle on. So anyway, to re-go over what I've lost, I found my bag of connectors, and this is the female one we need. And as I was saying, I bought these cable because when I tried making it, DIN plugs generally on the pin that you solder to have a hole in them, and these don't. These are solid. Both of them are identical, and all the ones I've seen online are the same. Now these must have a special slide-on connector that goes over these that you solder or crimp the wire to, and then they have a little insulating boot around them or something to stop them shorting. I tried soldering wires onto here, small wires, and they get very, very close to each other and can cause shorts, etc. Very fiddly, so I ditched that idea. And then I thought, well, I could wire wrap copper wire around the pins and then solder those, and then just put one wire onto one pin. But they're very, very close to each other as well. So that was a no-go, and that's why I decided that if I can get a male-to-male 13-pin cable, I'm going that way. And especially if it's wired pin for pin, which they are. So that's why I've gone that way. So I have me plug. We'll plug our plug into here. And this is just so that when we can meter from the plug to the wires on here. And I have drawn up a map on here of the back of this connector, and I've just labelled the pins from one to the other going across in rows. So 1 to 4, 5 to 8, 9 to 12, and 13 is the last one. And the bottom two pins down here are shielding for the cable, which is used for audio. Now the thing is we could probably, ouch, the sharp wire, what we can do is we could probably add that into the earth, I suppose, to screen the cable, to try and keep noise out. Something to think on. Anyway, that's done. I've written a pile of numbers down the side, and I've written cable under that, and I put an arrow across to MSX. So when I pin these out and I write the colours down the list, then I'll get the sheet of paper or the technical manual for the Yamaha for the pin out, and then I will go through and write on this side for the MSX what pin is what colour for what voltage, and so I can go through and do that. Alright, so, and I'm going to, when I've done this, I am going to wire it up so that it's just running off mains. So I'm going to directly wire the mains into here, and then the voltages I'll just wire them straight onto this, and that's just for proof of concept to make sure it's going to work. Then later on when I do it, there'll be the board in here which controls the power being turned on and off, and there'll be no power going into the machine until the machine is turned on. So the power switch that's going to come from the machine back into here is going to be very low 5-volt rail that's going to switch all these lines over to go through to the PC in the 5, 12 and minus 12 volt rails. Alrighty, so that'll all get altered later on when I put a circuit board in here. But I just want to get proof of concept for now, and then we can sort out putting the power switch in. The LED for this main unit, these have an LED on the board that comes on when they're powered up. So I may look at just taking a link off there and running the LED over to the lid and just linking it onto that. Alrighty, so I am going to go through and meter this up. You don't need to watch me doing this, that's simple stuff, guys. Alrighty, so I'm going to go through and do that, and then I'll come back when we wire up the plug and wire up this cable, and we can see how we go. So hopefully this one can get finished. Take me a little bit, not too much longer, to build a circuit board for that, and even on a bit of perf board or something like that, or copper sided development board, I can use something like that. Alrighty, so I am going to get on and meter this out and come back to you when I've got it all done. Alrighty, I will see you shortly. Right, so that's all done with the help of a socket and a pin connector and the old power supply that actually has a wiring diagram on it. That is the output of this thing that goes to the input of the other. So I started wiring this, and so I could go off this to which way around, which is this is wired that way, but these are the pins that go into the other machine, whereas these are the ones that come from the power supply going into that. So the way I had it written down on my piece of paper was exactly the same as what the pinout is for this, so that worked out good. So I've got all my colours coded and written down, and I will put this on the screen for you guys to see as well. So now I'll just clean all this up and I'll group all my wires together for what they are. Now this cable, when I was going through it, I noticed this has been made as a video cable as well. So this could be used for video, RGB, all sorts of things. So the nice thing is we've got a nice heavy-ish wire on on 2, 3 and 4, which are the RGBs on this. So they are actually quite heavy, so they will be fine for the voltages they pull through. The only one I'm a little bit worried about is checking out is the 5-volt rail. That tends to run on a whole pile of smaller cables. I'm picking it'll probably be okay, but I just want to see how we go, see how many we get grouped together. I think there's about 5 or 6 twisted together, which should be more than enough to pull through on the 5-volt rail. But we can only try it and see, and if not, who knows, we might have to try and get some connectors. I mean, these are the little round connectors I could find. Now these are very common online, another little round barrel jack ones, but the problem is that way too big for these for the connector on here. They're way too big. They're probably about twice the size they need to be. So I need to get them smaller than that. And then what I was thinking is that I could crimp up a wire with the smaller jacks. These can slide over, and we just have a bit of heat shrink over that. When we slide them on, then they don't earth to each other. And then we can have each of the ones connected together out on the one wire, and away we go. But we'll try this way and see if this fixes our problem. Hoping it does. Alright, so I'll just sort out all the coloured wires, group them all together, solder them all together as one wire, and then I'll probably just use a wire to go from here onto the power supply. And I'll wire up a plug on this so I can just plug it into my power supply over the back and just see what voltages we get out of it, and see if we're happy with the voltages that are coming through on the 5, 12 and minus 12. Alright, so I will be back shortly. I'll just get this stuff out of the way so we can carry on. Alrighty. Okay guys, so I've got my wires all on and set up, and I've heat shrinked the joins. So I've got red for me 5, I got yellow for me 12, I've got white for me minus 12, and I've got green for my ground. Okay, those are the colours I decided to go with. The white I put on the 12 volt because it's a smaller wire, and I didn't have a different colour in the same size as the others. The ground, well, that's where everything comes back through, and of course your 5 volts is heavy, and your 12 volts is pulling through 2 pins, so it's not as bad as the minus 12, but as the 5 as well. So I mean, so that's what I've got. That's what I've got here. So they're all heat shrinked up. I didn't use pin 13. There's also a 5 volt rail, but that goes through the earth. That goes onto this earth shielding, and I wasn't happy connecting that up, so I haven't connected that up. So hopefully there's enough on those 5 bolts there to run everything on those wires that it's using. So now I'm going to take this out, unwrap it, and connect up our wires to this, and connect up a power connector to this so we can run it. Alrighty, so I will move this out of the way. I'll take this out and take the plastic and that off it, and then I'll sort out a plug so I can wire into this as well. Alright, I will be back shortly. Alright guys, so I've got the plastic off the power supply. Go in the bin. So I've only found an isolated or an insulated 2-pin power connector, but it'll be fine to do this test. When I wire this up, I will use some 3-core or 3 wires. Now, to remember how you wire these up, so to remember how you wire up your wires is, even if you've got the newer one which has the yellow and green wire as well, is if you get hit, you become black and blue. So the old black colouring is now what they use for blue. The second one is that the red, is the green, and the yellow and green go together, so it's green. So that leaves you the brown, and brown is very close to red, so that's where the brown and the red go. But if you remember black and blue, then that's what those that's what those 2 colours go to. The red goes to the brown because it's the closest to red, and if it has the third earthing wire, which is yellow and green striped, then that is what the old green earth wire is for. Alright, just something to think on, guys, and remember. So what I'm going to do is, this is not plugged in. This is not plugged in at all. So what I'm going to do is just wire this up. So our live is hot, which is also red or brown. Alright, so we're going to put that one in the live connection. So on this it goes live, neutral, ground, 3rd voltage, 2nd voltage, common, 1st voltage. So before I put the connector to the plug on here, I want to check which voltage is on which one. I'm pretty sure it's 5 volt because that's adjustable. Then it should be 12, minus 12, or minus 12, 12. It'll be one way or the other. But anyway, live goes under for the blue. And, sorry. Now, who was watching that? It's AC, so it doesn't really matter because it's switching. But keep them colour-coded, because if somebody wires up a AC circuit and swaps them around, you could have mains running through what should be your neutral. Alright, that's why a lot of places are so pragmatic about it, is that you need to make sure you have your colours the right way round. And that's why, if you can, when you run a switch and it's a mains switch, try to switch both the polarities. So you want a double pole switch that when you throw it, it switches the phase and the neutral at the same time. Right, so that's got those 2 in there. That we can leave up because I need to check which ones are which on that. And so then that can come back and sit in here for now. Cool. And that also means I can adjust this. Now the other thing is that LED is down there, and it's a bit of a mission to pull this apart to get to what I want to get to. So what we can do is we can either get an LED and make up a little circuit so that when this is switched on, because the 5 volts the rails will be live here, but we're not having them switched over until we actually turn the PC on. So we can pull a 5 volt off here, drop a resistor in it, or off the 12 volt rail even. Probably off the 12 volt would be fine. And put a resistor in it to drop it down and run the LED off that. So basically when it's plugged in and turned on, it tells you that this is turned on, and then when you turn the PC on, the PC will turn on, and yeah, it'll power up. But anyway, I am going to plug this in, turn everything else off for now. Don't need all the others on. We'll plug this into here to make sure all the other plugs are off, because I don't want anything else coming on. Okay, and that's on. And I don't want that one on. Yep, I can change this around. Right, so I'll turn this on. Yep, now a little green light is on, which tells us that we've got power going into the unit. So it's a little green light down in here. It's probably a bit hard. Turn this light off and you might see it. See a little green light going in there? It's just down beside that pot. So that tells us that the power supply is actually on. So now what I need to do is get my multimeter and put it into DC. Lift that up, and common is the middle one. So from this to the outside one, that's our 5 volts. It's our 12 volts. And that's our minus 12. Not too bad. Yeah, it's not too bad. It's a 5.2, 5.3, that should be fine. So within 10%. So this little adjuster on the side, if we adjust that, that can drop the 5 volts down or raise it up. So that's what that is for. So if we wanted to, I just have to drop on a Phillips head. And so if we put that in there, the thing is when you adjust this voltage, it also slightly adjusts the others as well. Get a good connection on these. Then that's down to 5.1. It was on 5.3. So now if we go to the 12, so that's dropped a fraction, and the minus 12 has dropped a fraction. But I think 5 should be fine. We'll leave it at that, I think. And we now know that it is 5, 12, minus 12. So we can hook our wires into it and then check the power on the pins. Okay guys, so got my plug on the end of it. I'm just going to check these voltages. Now remember pin 13 is not connected, so we'll go on 12, we'll go to 1, 5 volts, 2 is ground, 3 is 12 volts, and 4 is minus 12 volts. So that's all cool. So we've only got one minus 12 volt rail. The other one is pin 8, which is that one there, which is 12 volts. The other 5 volt rails are 6, 10. So it's 4, 5, should be that one, 6, 7, 8, 9, and that one there, 10. Yep. So all those have got the voltages on them fine. So that's all working good. So what I will do now is I'm just going to double check with the old power supply with the plug in it that I have got it wired the right way, because you can go two different ways. You can either go left or right. and I'm pretty sure I've got it the right way around, so I just want to double check that with the old power supply, and if that checks out, then we can plug it in and see if it fires up the MSX. Hey guys, there we are. I'm almost at the finishing line. This is getting a little long, so I'd like to end it here. So we'll come back with a final video and round this whole thing up. Alright, as you can see, I'm taking my time and I'm doing things the right way. I will also in the next video be putting it into the new case. Keep an eye out for that and you'll see what the new case looks like, and I'll talk you through what I did. There's a couple of adjustments I had to do, but nothing a file and a sharp knife can't fix, a craft knife. Alright guys, so come back and see the final of this and see it all fixed and back together and powering up the MSX. Alright, as I always say, have a great day, have a great week, and until the next video, ciao.